Hi, good afternoon and welcome to the ZP webinar on food sense. So it's afternoon for us, but it may be morning for you. That said, I'll go forward quite quickly. We are doing these webinars today in conjunction with our distributor in India, who's called Technando. We do find that different regions basically end up with different sample types. So in India, there's a lot of green chili and also a lot of chili powders being tested and also a layer resins being tested. So if you're in India and you've got any of those sample types, these are definitely things that we test or can be tested rather on the Food Sense Generation 4. If you're in the US, it tends to be more things like hot sauces. You'll see some videos on Ed Curry's channel featuring Zimmer and Peacock. Ed Curry's the guy who grows Pepper X, and you'll see Ed very politely introduces the video as it's a bit long, but it is a bit long, and we did some testing, and you can see that on Ed Curry's channel. So in the US, it tends to be a bit more hot sauces. With that said, today is sponsored by Technando, who are our distributors in India. With that said, let me go forward very quickly. Now, I'm about to show you a URL or web address. This is really because actually the whole technology that we're going to be talking about, and when I've been talking about, I'm just going to change cameras real quickly and onto a device. So we're going to be talking about Food Sense Generation 4. Food Sense Generation 4 works with an app. Now that app is something that you can download off the Apple App Store or the Google Play Store. All of these words will become a little bit more apparent in a minute, because what I'll do now is I'm sharing my screen. I'll just change cameras just real quick and just go forward with why I'm saying all this. So you can follow some of this demonstrations later on if you so wish, and know that the Food Sense Generation 4 does a rapid measurement of the Scoville heat unit of chili, chili powders, layer resins, chili flakes, chili oils, hot chili sauces, a whole host, even these hot Korean noodles we've done testing on. The start of the journey is actually there's a cloud system called Julie. If you register on Julie, use your email and create a password, that creates you an account. Later on, then you can actually on your phone put a app on your phone. So there's an app. It's called Sense It All. Sense It All is the app that governs the Scoville meter, and it's what transfers the data up to the cloud later on. In order to get hold of that app, you can scan this QR code. Just before you go and do that, by the way, all of this is useless unless you've actually got the food sense meter. But I'm just giving you a preparation for what's going to happen today. So if you scan that QR code off your Android phone, then you can basically install the app on your Android phone. And if you scan this off your iPhone, then you can install the app on your iPhone. As I say, today's webinar is sponsored by Technando. And so if you're in India, then Technando is your point for contact. The Food Sense Generation 4, I would generally say that 90% of people using Food Sense Generation 4 are actually doing chili detection. So most of the support we give on Food Sense, most of the literature we've got on Food Sense, actually the academic papers behind this are actually on Food Sense specifically for chili. But we've also done ginger. It's a much let's say smaller user base. It can also do pH, it can also do total antioxidant capacity, it can also do glucose, but most people are definitely doing chili testing. When I say these statements, Food Sense Generation 4 is a rapid test. I'll do a quick demonstration in a minute. I think it offers I know it offers a low cost per test, especially when you think about the alternatives. The alternatives to the Food Sense Generation 4 are you've got a chili product or some chili material, it's got capsaicin in it. You're either not testing it at all, you're either just tasting it, which I call organoleptic. You may on occasions use HPLC, but you probably don't do that quite as often as you would otherwise want. And the reason you don't is because it's expensive to do. So the cost per test means that you can do a lot more tests because the alternative objective test is HPLC, which is probably inhibitorily expensive for most food production. This is an objective test. I'll illustrate what I mean by an objective test, that this is not just a number on a screen. We actually record the raw data. And the fact that we record the raw data means that we have a high level of transparency on this. So what I mean by that is you will get a result on your phone, but you will also get the raw signal behind that result saved up into the cloud. So the analogy to this is, at the moment, if you sent a sample to HPLC for HPLC, it's going to be expensive to send that sample. It's going to take a while to get that sample, and what you'll get back is a certificate of analysis. But there's actually a lack of transparency on that, because in fact, that certificate of analysis doesn't show you what's called a chromatogram. That's the raw signal behind that actual number. With Food Sense Generation 4, you get the number, and you get the raw signal behind that number as well. And it's also got excellent traceability. So the traceability comes from every time you do a test, it knows who did the test, it knows when they did the test, it knows the date at which they did the test, so there's time and date, and it has the raw signal, and it saves the number as well, and you'll see that in a minute. So you can use this as an incoming quality control, you can use this as a process quality control, or you can use it as an outgoing quality control system. I think that the fact is this is the only system that really allows for process quality control, because you can do such rapid testing. If you are blending some chili powders or making a chili sauce, you could actually test in real time to see how hot the Scoville heat unit is, and you can bring it to the required hotness by just doing testing and blending, testing and blending, testing and blending. So it's the only device that gives you sort of the ability to do real-time testing, let's say, or real-time process control, I should say. With that said, we have tested a lot of samples along the way. Things like complicated samples like mayonnaise. A spicy mayonnaise is quite complicated. There's a lot of oils, a lot of fats in that. We've tested these sauces from a company called Nando's. Nando's is, I think the company's based in South Africa, but they own a large chain of restaurants, at least in the UK. They do some hot sauces. We're definitely testing some chili oils, even chili honeys. I mean, there are, so the reason I bring up all these different sample types is because we can deal with an awful lot of sample types. This morning we were asked whether we could test Olea resins. If you ever Google Food Sense Generation 4 Olea resins and testing, you should find a video on YouTube about us testing Olea resins. We've even tested the bomb. If you've ever seen a YouTube channel called, I think it's called Hot Ones, where they interview kind of Hollywood celebrities, and these Hollywood celebrities are eating increasingly hot chicken wings, then those sources have actually been tested on the Food Sense Generation 4, including this extreme, and we've also tested chili powders. I think the biggest testing of chili powders is actually taking place primarily in India, and I think that's because of that's where the production is generally happening. And then we've also tested things like ginger shots as well. As I say, 90% of people, if not maybe even higher than that, are actually really testing chilies. So we do carry other tests, but it's chilies that are really being tested. Just as way of background, we don't spend a lot of time actually introducing Zimmer Peacock, because we really want to give you value by actually doing tests, doing technical discussion. But it is important, especially from a business to business relationship. We've been around for 10 years now. We are ISO 13485, so we're qualified for the manufacture of medical diagnostics. So when you look at Food Sense Generation 4, what you're really looking at is something that looks suspiciously like a medical diagnostic. And that's because that's actually what we do most of the time. We have a nice, large, diverse team, and we're pretty good at support. So everyone gets personalized online training. We do weekly webinars. So, if there's a technical question coming during the week, we'll have answered it within that week because of the weekly webinars. And then we do monthly webinars as well. And the monthly webinars are also important because you can have a certain turnover in businesses. And so if somebody's got trained on Food Sense Generation 4, but then there's somebody else new coming into the business because somebody else left, then you can always be assured that actually there is one of these monthly webinars where we do, at least a high level introduction. This is something that we recently did for a client who was actually testing some chili powders. They were having a few issues, so we wrote them what's called an SOP, a standard operating procedure, so that they could really we were helping them what's called RSD, relative standard deviation, just making sure that their testing was nice and precise. Just way of history on food sense. Food sense has been around for quite some time now. This is actually generation 4. So generation 1 was, you'll find this on some old videos online. But that was generation 1 product. Then we had generation 2 product. Then we had generation 3 product. It's important to understand all these generations of products because as the longer you go with a product, the more refined the product becomes. And so, with the fact that we're now on generation 4, you can understand that lots of lessons have been learned, lots of improvements have been made, lots of customer feedback's been incorporated, and now we have something that is really world class, I would suggest. I'm going to make a few statements here, but I'm actually going to back these statements up with a quick demonstration. This unit is quite small. You'll see that in a minute. You'll see that it's easy to use. And I challenge anyone to claim that this unit is not easy to use. There are videos online. If you look up Zimmer Peacock and Child's Play, for example, and Food Sense, you will find videos online where literally people under the age of 18 can run this unit without any training because it's so intuitive. In fact, I've got the manual here, and I think the manual is in part an explanation as to we've just shipped one of these to the US, and I can see already that they're just getting on with it at the moment. Because really the manual is it's thin, but it's thin because it's actually reflecting the level of detail actually in this manual, and it also reflects the fact that the instrument is very intuitive. It tells you where to get the app from. It tells you how to turn it on. There's only one button on the instrument. It tells you how to run the app. It tells you how to connect to the device. It tells you how to put the sample on. It tells you how to tell the instrument what dilution you've used. It tells you that the data is uploaded. So it's really quite a thin but comprehensive. And once upon a time, we thought we would have to do a lot of training, but actually now I'm starting to find out that people are just getting on with it. It's more accurate than its predecessors. It's cloud enabled. This cloud enabled is significant, and you'll see the significance of it. We do a lot of support because when people first get hold of Food Sense Generation 4, first question they have is, well, does it look right? Is it working? And we can actually answer that question really quickly because it's cloud enabled. So you every time you do a test, you'll get a result on your phone. Great. But actually, every time you do a test, it's also saving the data to the cloud. And if you want to share it, if you're in India, you can share it with Technando, or if you want, you can share it with Technando and Zimmer and Peacock, and we can all look at your data and give you some confirmation that things are looking good. It is multi-analyte, but to be fair, most people are actually using it as for measuring chili products. What I want to do now is I just want to stop for a second because I've got a lot more, let's say, slides, but I think I want to put a bit of context into some of those comments. I said it's easy, it's quick to use. So what I'm just going to change screens for a second. Now, I do have a colleague online who's actually going to give you, also going to give you demonstrations. So you're going to probably see quite a lot of demonstrations very shortly. But what I want to do is I'm just going to give you a quick demonstration. So what I'm going to do now is I'm just going to take this sensor out. I'm just going to bring in a new sensor. All I want to do at the moment is just show you how easy it is to kind of load these sensors, how easy it is to just click them in place. It really requires a very small sample. So when we say 50 microliters, 50 microliters is like a drop size, let's say. So I'm going to take that sample. I'm going to put it on the sensor, which I'm doing now. I'm just going to give that a quick name. The reason I'm giving it a name is because later on I want to find it and I want to show you. Go to assay. I did what's called a 1 in 10 dilution, start measurement, and off it goes. This is the beauty of this. At Zimmer and Peacock, we come from the medical diagnostics industry. And if you're dealing with patients and doctors, patients literally have no patience. They will actually want to just get results. They don't want to hang around for their glucose reading, etc. So in fact, we're very used to developing, let's say, assays that are really fast. So that's a kind of the mentality, let's say, at Zimmer and Peacock. So I've got the result here now. This is perfect. So I've got, what I'll do is I'll change screens for a second, just so you can sort of see that a little bit better, if I can, if that's the right way to phrase it. So I've got a result on my phone. If you read that result, I think it's saying 5,560 Scoville heat units. And what I'm going to do is I'm going to share my screen with you, because we got the result, but this is the bit where I say it's cloud enabled. It's gone up to the cloud. I can click in here. I can see my signal. First of all, this is today's date. This is the time. This is the signal. This is the value. So you don't have to be wondering what this means. And I get a fingerprint for capsaicin. Now I'm going to give you a few slides in a minute about this. But if you're ever challenged, well, is it working? It's like 1, 2, 3. You can see that that's like a very distinctive, pattern, and you're going to see that appears a lot. So who did it, when they did it, what date they did it in, or what time, what date, the raw signal and the number, transparent and traceable. It's all up in the cloud. And so this is this is a product of 2024. The fact that you can get a result on your phone, nice and simple, and it's saved to the cloud. 5 years ago, products like this wouldn't have been possible, but today, as you can, as we live in this age now, actually these kind of products are possible. In the box, you do get the meter. You get a nice manual. The manual is kind of very clear. Like I say, you can have. You wouldn't use children to run it, but children can actually run the unit. There's only one button on this unit, on off. Even that button has an LED on it, so you can kind of know that that unit is it's rather been turned on. Nice little case, so everything is kind of slotted in there, including the sensors, the cable, and the chili pot itself. This is what the unit looks like. I just did that quick demonstration, so you probably got a sense of scale when I did that demonstration. When you buy it, you get 500 milliliters of buffer. When I just did that test just now, I used about 1 milliliter of buffer. So yes, about 1 milliliter of buffer. So I could have got 500 tests with that particular buffer. And yeah, these are the sensors themselves. I'll hold them up to the camera now as well. You kind of just snap them off from these cartridges. They're easy to handle, easy to slot in. So if you so wish later on, you can open up a Julia account. But to be honest with you, what I'm describing is only useful if you've actually got the hardware. But just to say, the app is available on the Google Play Store, and the app is available on the on the Apple App Store. You can scan these QR codes to go between different analytes, but to be honest with you, I think most people are actually just doing chili. So the unit, as you saw me snap it in earlier on, goes into the meter. The meter is told what to do by the app. The app will give you a result on your phone screen, but at the same time, it's sending the data to the cloud, and it's storing not just the number, but the raw signal, the operator, the time, and the date. And you can go in there and see it. And if you're worried or concerned, or you want to kind of get some backup, because it's in the cloud, you didn't even have to email the data. You can invite. It's very important I use the word invite, because neither Technando or Zimmer and Peacock can see your data unless you invite us to see your data, and you possibly will do, because you want, when you first get an instrument, you'd like to know, is it working? And we've seen people who have, they're either too little capsaicin or too much capsaicin, or they've processed the sample wrong. So we are pretty good at troubleshooting and this kind of technology. I'm just going to describe, because when I was earlier on, when I did that quick demo, and I just clicked back to that demo real quickly, there were these peaks in there, and I said, oh yeah, look, it's capsaicin. Well, I want to now explain, how I know that is capsaicin. So I'm going to go back to the original, let's say, invention of this. So this originally came out of the University of Oxford, a gentleman called Professor Richard Compton, and Zimmer Peacock essentially licensed the technology. Now, Richard appreciates, and I'm sure you do as well, that actually the molecules that give you the sensation of hotness are called capsaicinoids, or capsaicin is the sort of biggest, let's say, one among all of those, and it's what gives us the hotness. Now, the instrument, you'll hear Solron mention this when she does her demonstrations as well. The instrument is doing a technique called cyclophotometry. That's not important to your operation of the instrument. We only make that statement because then it's clear to you that, we understand the science behind it, but it's actually doing this. So when you watch Solron's demo in a bit, you'll see a progress bar. Solron will make the statement while that progress bar is running on the app, it's actually doing this experiment. This experiment gives us a very distinctive 3-peak signal. What do those peaks mean? Those peaks mean capsaicin. Where are they coming from? We're using a technique called cyclophotometry. I can talk about this because this technology is patented by the University of Oxford and licensed by Zimmer and Peacock, so it's IP protected, or intellectual property is protected. So we actually oxidize the capsaicin, and in oxidizing that capsaicin, we get what we call peak 1. I know this is very much electrochemistry, and I only say it so that, when you see these peaks, I'll talk about peak 1, peak 2, and peak 3, and you'll know that there's a genuine origin to these peaks. The peaks tell you it's capsaicin, and the peak heights tell you how much capsaicin is there. So when the progress bar is running on the app, it's secretly doing this in the background, and that's peak 1. So that's the first indication that this is capsaicin. And then essentially the analysis carries on. We get something called peak 2, and this is peak 2 now. So now I want to explain what peak 2 is. So let's go on to peak 2. We form peak 1, the molecule capsaicin, and it then actually undergoes what's called hydrolysis. It just means it's reacting with water, and we form a new molecule, and this molecule is what leads to what we call peak 2. So then we get what we call peak 2. So when Solron does a demo, or I do a demo, you'll see peak 1 in the raw signal. You never have to deal with this, by the way. The result, we will actually have analyzed it and just give you the Scoville heat unit, but this is peak 2 now. So this is also due to capsaicin. And then there's actually the analysis continues, and we get a new peak. Here it comes, peak 3. So peak 1 is due to capsaicin, peak 2 is due to capsaicin, and peak 3 is also due to capsaicin. So there's another what we call oxidation, and in doing that oxidation, peak 1 with the original oxidation, then we get what we call it a reduction. Here it comes. And then there's a new peak when we what we call cycle back round. So here it comes. And if you get this peak 1, this peak 2, and this peak 3, you're then knowing that you're actually looking at capsaicin. And as I say, this is both objective, it's qualitative because it's capsaicin, and it's quantitative because actually these heights are proportional to how much capsaicin is in there. This is really akin to HPLC. And HPLC, they will high performance liquid chromatography. They will take your sample, they will extract the capsaicin, they will record a chromatogram. The peak heights in the chromatogram are proportional to capsaicin, and they calculate the Scoville heat unit. And so it's really the equivalent. Now, I want to talk here about hotness of products. So if you're dealing with something that is like a chili sauce, this is quite mild. So I'm holding this up. You would do what's called a 1 in 10 dilution. Maybe it's some chopped up mild chilies. In that case, you would do a 1 in 100 dilution. If it's a chili powder, you may do a 1 in 1000 dilution. Now, I'll talk about the reason we're doing that in a minute. If it's something like a Carolina Reaper powder, so one of the questions that's come through in real time is how effective is this for the higher pungency chili products like 60,000 to 70,000 Scoville heat units? First of all, 60 to 70,000 is not super high. This morning we did a demonstration this morning, and there Solron recorded Carolina Reaper powder, which is 1.5 million Scoville heat units. So we've got to be super clear on this, that 60 to 70,000 Scoville heat units is not super high, especially in the scale. This unit can effectively operate from 0 is a silly kind of number, but 16 million is the top of the Scoville heat unit. So we're designed to be able to run between up to 16 million Scoville heat units. So 60 to 70,000 is not super high. When it comes to HPLC analysis, there are some independent reviews out there on HPLC. There's a gentleman called Charlie Rower at the University of Minnesota who has published 2 peer-reviewed journals where he's actually looked at the food sense versus HPLC, and he makes a good recommendation on food sense. Now, ZP's obviously done our own analysis, but Charlie Rower is independent of us. He bought the unit himself. He did his own testing. He paid for his own HPLC analysis. And in his paper, he actually tests his samples on the food sense in triplicate because he can afford to do it in triplicate. Whereas with the HPLC, he can only afford to do it once because it was actually costing him $100 to do it. So the quick answer is, what problem with HPLC is, I don't think there would be no food sense generation 4s being sold if HPLC was good. But the reason we're having this conversation, the reason people attend these webinars is there's a problem with HPLC. It's too expensive. It's too slow. They're not doing as much testing as they want, and there's no transparency to it. Whereas if you go and read the papers by Charlie Rower at the University of Minnesota, you will find independent scientific comparisons between our 2 methods. Now, what I'm going to do now is I'm going to just stop sharing for a second and swap monitors. Swap cameras rather. I want to do a quick demonstration to you, but I want to do a demonstration when I'm going to make a deliberate error. So I'm going to show you that this technology is actually smart. It's basically watching your back. So what I mean by watching your back is this: I'll take a sample, and I'm going to deliberately going to make an error here. So I'll take this sample. I will put it in like that. I'm just doing this really quickly and making lots of mistakes when I do that. And now I'm just going to dilute that sample a little bit, but only a little bit. What I'm doing is I'm making a deliberately saturated sample. So I'll just do that. Right. So I've just prepared a quite saturated little sample, and I'm going to put it on here. Because if you're going to be testing something that's 60 to 70,000 Scoville heat units, then that probably suggests that you would want to do what's called a 1 in 100 dilution or 1 in 1,000 dilution. But you may ask yourself the question, well, how do I know which one to use? So I'm going to answer that question by doing you a quick demonstration. So I've just set up a quite hot sample. And what I'm going to now do is I'm just going to quickly vortex this. Give me a second. This is just to homogenize this sample. Yeah, so now I have homogenized it. Now I'm going to put it on the sensor, and let's get a reading. Right, here goes. You can see how quick it is to actually prepare a sample, and I will just give this a name, which I'm doing now. 13. And I'll run it. Right. So earlier on, I was waving my arms around a bit and talking about cyclovoltammetry, and I said that Solomon would talk you through it. I'll also talk you through it as well. On the app, there's a progress bar, and when it's doing this, it's basically running a cyclovoltammogram. As I say, this is IP that we've licensed from the University of Oxford. That we've done all the development on it. At the same time, there's a nice flashing light on the front of this unit, which is actually telling me that this is progressing. Here it goes. And it's come back, and it's given me the Scoville heat units of 5. Oh, there we go. That's what I was waiting for. It said too high, dilute more, upload complete. So too high, dilute more, upload complete. Now I want to explain what that means. So what I'm going to do is I'm going to quickly refresh the browser that I'm in. Let me just clicking around a bit so I can share my screen with you. Yeah, there we go. Right, cool. So what I'm going to do is I'm going to share my screen with you. I'm going to go, because the test has gone up. Bang. Right. The app said to me, too high, which basically means too much capsaicin. It's told me what to do. It said dilute more, and it said upload complete. So if I go and look at the data in the cloud, you see the way that is flat like that? That means there's too much capsaicin actually in this sample, and the system is smart. And what I mean by smart is it's basically looked at the data. So you didn't have to be an expert. So let's say you've got a 60 to 70,000 Scoville heat unit sample and you do a 1 in 100 dilution. But in fact, it's still too concentrated. The unit will tell you what to do. And if you over dilute, it will also tell you what to do. And you can just go in, you can look at your signal and say, well, that doesn't look like what Martin showed me in the webinar. It's flat line, but that flat line means that it's gone outside of the instrument. So the instrument is smart. You can see it even here as well, that we can see all of that. So 60 to 70,000 Scoville heat units is not so hot, in fact. I do have some, there's a source out there called Da Bomb. Da Bomb is about, they say on the bottle it's 135,000 Scoville heat units. It's actually more like 170,000 Scoville heat units. The reason that sometimes products are not as accurately reported in their Scoville heat units as they're not accurately reported is because actually nobody's really doing that much testing, because the cost of test on HPLC means that you can't afford to do a lot of testing. So if you're in the range, if you think you're in the range, I would suggest 60 to 70,000 Scoville heat units, then you're probably going to be doing a 1 in 100 or 1 in 1,000, but you didn't have to know. The app is smart. The app says here, too high, dilute more, and upload complete. And you can just go and look at that data. You can see that, you can see the way it's kind of flat line like that. It means it's gone outside of the instrument limits, and you're sort of advised, therefore, to dilute more. And I could dilute that and I'd be fine. So I say here demo. So what's going to happen now is I'm going to quickly turn my camera off. I'll mute myself. I'm going to hand over to a colleague called Solron, and Solron's going to talk you through. So good evening, Solron.
Hey.
This is London calling.
All right, Norway calling, Norway answering. So I will run a quick test, like Martin said. So let's take a quick look at the device. So here's the device. It's designed for us to work in the lab. We are using this on a regular basis, and there's been put a lot of thought into the device in order to keep it clean and to avoid contaminations. So the pins are coming from above, so if you're spilling, the device is not ruined. What we will start by doing is to insert one of these sensors into the device. So we'll insert it like that, and then we will start preparing our sample. I will quickly show you what it says in the app. So this is the Sensible app that Martin showed you. It says that the device is connected, and it also says that we have chosen the chili sensor assay. We can choose another assay real quick by clicking the button next to the chili sensor. And you can scan a QR code, and I'll scan the QR code for chili sensor, and we're back on track. Next thing for me to do is to change the test settings. So I will change the sample ID to say sauces, and I also have the cluster name, which is for me to where I will upload the data. And then I will click Go to Assay. Here is the instructions. It guides me through every step in order for me to test my sample. So I need to choose a dilution factor, and today we will be testing Apollo, which is quite pungent. That is why we will choose a dilution factor of 1 to 1,000. It says to place and lock the cartridge, which we already did, and it also says to mix the sample. So we need to prepare a sample of 1 to 1,000. I will shake it a bit, just so that I get as much of a homogeneous sample as possible. So now I'll show you close up what I will be doing. So I'll change to this view. Okay, and then I have a Petri dish. I will just pipette. I'll pour out some sauce onto here, just so it's easier for me to pipette it. And then I'll use the chili pop buffer here, and I will add that into a vial like this. So let me show you in this view. So in order for me to make it 1:1,000 dilution ratio with the sauce, I will use 40 microliter of the sauce and 40 milliliter of the buffer. So 40 microliter to 40,000 microliter of the buffer. So that gives me a 1:1,000 mixture ratio. So 20 milliliter, I just need to add 40 milliliter, 30. And I just want to do this on camera so that you see that I'm not cheating. And these sensors are really easy to test. So actually, it's the sample preparation that takes the most time. Because as you can see, Martin had already run through a couple of samples. So what takes time is the sample preparation. So now we have 40 milliliter of this buffer. Next thing we will do is to add some 40 microliter of the sample. So I will change the pipette to say 40 microliter. Right. Okay, and like that. All right. So yeah, so you might encounter this as well. Sometimes we have samples that have chunks and pieces. So if you have a very chunky sample, you might want to weigh it out rather than using the pipette. So I just had to work it a bit, but eventually it worked. So here you see. So I will show you in this view now. I'll add it into here and I'll mix it well. So it's quite a small portion compared to the buffer, which says something about just how pungent it is. So you see that it's accumulated on the bottom here. So I'll shake it a bit and I'll use the Vortex. Vortex is a tool we oftentimes use just to get as much of a homogeneous sample as possible. So sometimes if you have very chunky samples, for instance, you'd even like to leave the sample on the bench for some hours, just in order for it to really extract that capsaicin from the chunks and bits into the electrolyte or into the solution. So here you see it's not really only at the bottom, but it's distributed around the sample. You might not see it, but you can see some chunks and bits floating around, and that is okay. You will maybe see that with your samples as well, but don't fear. It's the capsaicin is being extracted from the chunks and bits into the sample. So even though you add the sample onto the sensor and you still see some chunks and bits on the sensor, that's completely fine. Don't worry about it. So and now I will show you the close-up view again. So according to the app, it says to add 50 microliter of the sample to the sensing area of the sensor. So that is what we will do. We will take a pipette and we will pipette 50 microliters onto the sensor. Just like that. This. And then go back to that and we'll click Start Measurements. So now you see a progress bar that Martin was showing you, and he also said that I would talk about cyclical tomograms, which I will. So right now it's running these cyclical tomograms that you saw that Martin presented to you, where you had those 3 peaks going on. And it's running that in background. We're showing just a simplified look where you have the progress bar, and it's also uploading the data and analyzing it in our data platform, Julie, which I will also show you. Okay, so it says too low, dilute less, upload complete. So Martin also went through this where the app is sort of instructing you what to do. So it's very smart in that sense, which is very convenient. So it helps you with how to sort through data or
let's have a look just for interest. Let's have a look what the data looks like.
So we'll go to Julie. So here it is. I need to refresh in order for it to show. So here it is, sauces. And here you see the data. So you see, yeah. Okay, so it's a bit distorted, the curve. So ideally we would test it again to see that the dots were the area in which is being analyzed didn't appear at the peak. So
but that's I mean that's not bad. That's not bad though, because basically that would mean that you should really do that sample as like a 1 in 100, for example.
Yeah.
So I did one that was actually too concentrated and it was kind of off the scale. And then you did one that was actually, let's say, you over diluted by doing 1 in 1,000, and it told you the opposite to me, which is you're too dilute and I was too concentrated. Just for an interest, do that sample at 1 in 100. Let's have a quick look at it. Look at it at 1 in 100.
All right. So then I just need to prepare it. So give me 2 seconds. So also worth to know is that these sensors are one-time use sensors, because the capsaicin very much loves the surface of the electrodes. So the capsaicin will accumulate onto the sensing area. So what I will do now is I will do 4 milliliters. So I've reduced it by a factor of 10. So 4 milliliters of the chili pop buffer, and I will add still 40 microliters of the sample. So just need to adjust the pipettes. So here we go. We have okay, so we'll do 4 milliliter. Okay, like that. And then I won't do the same mistake as I did earlier. I will actually add the sample yet again, because maybe I took the sample from the edge where only the where some of the more liquid part of the sample spread. So I'll try to sample it right away, and you can see that it looks quite different, those two. So I think it had with the homogeneity of my sample to do that, the fact that I got such a low count or low school heat units.
But this is the classical problem, see, that real samples are very heterogeneous. So what happens is people take a sample and they make this assumption that they take this sample, they send it to the lab, and they make the assumption that that sample is representative of everything that they have. Actually, it's not the case. That, if you ever look at a chili powder, you will see that actually, it's got different colored bits in it, and it's actually quite heterogeneous. And earlier on, I was making this kind of claim that actually it leads to what's called a lot of under testing. So if you truly want to know the average Scoville heat unit of a product or an incoming material, you have to take samples from different places within it and actually test them, so you can get essentially an average result. So that's a very good point, see there, that you took it from the very runny part of that source, and in fact that was the lower in the Scoville heat unit. So yeah, carry on.
And it is really my mistake, because I'll show you close up. If you look at the bottle, like you can see that it has sort of become more solid here at the neck, and I just didn't account for that. Like I didn't shake it enough. Like I should have mix it better, because I got bit of a heterogeneous sample since I've been leaving it on the bench for such a long time. It's not a fresh sample. It has been opened and closed and opened and closed. And the result you can see here in the Petri dish where you have where I didn't take
So let's get
too
that
much
sample on
the
that
first time.
sensor and let's have a look at that result now.
Yeah. So here we go. Okay, 50 microliters. I'll click go to assay. So this time I have a 1 to 100 dilution ratio. I'll click start measurements and I'll wait for it to finish. And I fear that, well, maybe not. Let's see if it comes back as too high this time, or
Yeah, that's what I was
if,
wondering as well. That's because now
yeah,
you've taken a hotter thing and only done 1 in 100,
yeah,
but
yeah, yeah.
it does demonstrate that the app is quite smart, that it actually looks at the data and gives you feedback. It told me that I was too concentrated, and it told you that you were too dilute. But tell me
Yeah.
what you're seeing now.
So it says 67.8 thousand school heat units. So I think that's pretty decent. It's pretty budget. So let's have a look at the data in Julie. We'll click refresh. The new data appears, and here you see that the peak is so much more distinct than before. And it shows where in that range it's analyzing the data, and also here it states the school heat unit counts and the molecular molarity depending on your preference. Yeah.
That's great. Thank you. So that's really useful because I can't quite see it, but I think you're telling me it's about 67,000 Scoville heat units,
Yeah.
which is really useful because there was a question in the comments about how about measuring products in the 60 to 70,000 Scoville heat unit range. And I think Solrun there has kind of done a nice demonstration that it wasn't planned, but she used a fairly hot source, and that one is actually in that kind of range. I was when you showed me that source, I was thinking, oh, that was a bit a bit coincidental, but anyway, good job, Solrun. So, and you can see there that actually this app is smart. See, so it's sort of the AI on this is guiding us into the right dilution. It told Solrun that she'd over diluted it when she did the 1 in 1,000, and then she did the 1 in 100, did a few corrections, and there's the results. Now in that time we've probably tested. I think I've done 2 tests. Solrun has probably done 2 tests. So that's 4 tests done with a lot of talk in a 45-minute period. So in summary, this is quick. It's easy to do. It works fine in the range 60 to 70,000 Scoville heat units. If you attended our webinar this morning, you would have seen us do a 1.5 million Scoville heat units sample. And I think if you've got any questions, then we do have very good support in India. If you become a user of this, you get you get personal online training to start with, you get weekly webinars, and we also do these monthly refreshers as well. So with that said, I appreciate it's getting late. Not late, but in Norway it's getting late. In London it's getting late-ish. I appreciate it's very late for you, for Technando, who's joined us online from India this evening. So thank you very much for that. And if you have any questions, if you're in India, reach out to Technando, and if you're in the rest of the world, then reach out to Zimmer and Peacock. But I just want to say a special thanks to Niti, Aftab, Solrun, and have a good evening. Okay, take care. Bye bye.